everyone. Welcome again to my YouTube channel, Python All Day. We call it Python All Day because Python is a very powerful language. And as you continue your programming journey, you will come to value the power of Python. That's why I always tell people, please learn Python. It's truly beautiful and also quite magical. In any case, today I wanted to talk about data types, Python data types. And one thing to be aware is that Python, being a dynamically typed language, automatically assigns data types to variables as you create them. That being said, understanding the different Python data types is essential for writing efficient and error-free code. Python provides several built-in data types which can be classified into various categories. In this tutorial, we will explore the major data types in Python, how to use them, and also their unique characteristics. To start off, we'll start with numeric data types in Python. And Python has three numeric data types. It has integers, otherwise the ones we refer to as int. It also has floating point numbers, otherwise the ones that we refer to as float. And it also has complex numbers, otherwise the ones that we refer to as complex. Complex numbers are not that much commonly used as integers or ints and floating point numbers or floats. To start off, I want to start with integers, and essentially integers or int are all numbers that can be either positive, negative, or zero. For instance, let's say that we have a variable called x. So if we have a variable called x, and we want to assign this variable to an int, the way we assign to variables, we use the equal sign, and we can assign this to 5. And now this variable 5 is an integer. We can also assign to 500, that's an integer. We can also assign to negative 500, that's an integer. So integers can be positive, negative, or 0. We can assign this variable to 0, and that's also an integer. So integers are all numbers. That's the most important thing to understand. All numbers, they can be negative, positive, or 0. That's an integer. We will see different operations that we can do with integers as we continue in the introduction series on Python. There are common operations like addition, subtraction, and multiplication, division. And they also we can also use them with special operators that we'll talk about as we continue with our Python series. Special operators could be things like modulus, exponentiation, and floor division. But we'll talk about this as we continue, particularly when we talk about operations in Python. But for now, I just want you to know that Python has three numeric data types. They are integers, floating point numbers, and complex numbers. Floating point numbers, these are numbers that contain decimal points. Any number that contains decimal points in Python, that is a floating point number. Otherwise, we call them float. And the way you write float is with a small f. Small f, L-O-A-T, float. And most of the time, the floating point numbers are used for precise calculations, as would be done in financial or scientific data. If our variable x here was 0.9, then that's a float because it has a decimal point. 0.7, that's a float. It can also be negative 0.7, that's also a float. Any number with a decimal point in Python, it's a float. And the point with floats to understand is that normally Python stores floats using double precision, 64 bits, and that provides high accuracy, particularly with calculations. And then we have complex numbers. Complex numbers, otherwise known as complex. And in Python, complex numbers are represented as a combination of a real number and an imaginary part of the number. So they are represented as a combination of a real and imaginary part. That's a complex number. You have a real part and an imaginary part. Like for instance, let's say we have a complex number here. We have a variable called z, and we say z is assigned to, if we assign z to maybe say, I want to assign it to something that's a little 2 and 3j. So we can say z is assigned to 2 plus 3j, like that. So this can either be lowercase j or uppercase j. It can either be lowercase j or uppercase j. And in Python, so the j, the imaginary part is denoted by j. This denotes the imaginary part. So that part, so this is the real part, and this is the imaginary part, the 3j. And the 2 is the real part. Then the 3 is the imaginary part, and the j is the unit for the imaginary part. And so this is a complex number. This is a complex number data type in Python. And if, for instance, we have another one here called k, and we have this complex number k equals to 4 plus 3, or maybe 8 or 9, 8, maybe let's say 8, j. Remember, it has to be j. The j can be uppercase or lowercase. So we have j there, and j. And here, if we say, for instance, print, we want to add z plus k. Z plus k. What do you think the result is going to be for this addition of complex numbers? What do you think it's going to be? So it's very intuitive to add and subtract complex numbers. The way you do it, you take the real part and the complex part. You add the real parts together and you add the complex part together, and that's how you do addition for complex numbers. So we say 2 plus 4 is 6, and 3j plus 8j is 11j. So this is going to be 6 plus 11j. That's going to be the result of this addition. I can click on run here, and we have 6, 2 plus 4, 6, and then 11j. 8 plus 3 is 11j, and you can see the result that we got here is 6 plus 11j, but this is pretty much an introduction to data types, and I just wanted you to be aware that although we don't routinely use this as we use integers and floats, it's also a data type, a numeric data type in Python that you can utilize in case you need to. Subtraction is about the same. We subtract minus and we see the result. We get negative 2 and negative 5j. 2 minus 4 is negative 2, and 3j minus 8j is negative 5j. But that's how we do some simple operations with complex data types in Python. This is a complex number, and I just wanted to introduce you to the concept. So at least, even though you won't be able to use it a lot when you are coding with Python, at least it doesn't hurt to know that it's there and it's something that you can utilize if needed. So those were the numeric data types in Python. They are integers, they are floats, and they are complex numbers. Then I want to talk about sequence types, sequence data types in Python. And Python supports several types of sequences which are ordered collections of items. Very good example of a sequence data type in Python is strings. Strings, also we call them str. So strings. And this, we also denote them as str, string data type in Python. And strings are normally used to represent text and enclosed in single or double quotes. They are immutable, meaning that once created, they are immutable. Strings are immutable, meaning that once they get created, they cannot be changed. And a very good example of a string is the most famous one, hello world. So we can say maybe my string, that's my variable. I can assign this to hello world, and this is a string. This is a string data type in Python. And we'll see about string operations like concatenation, repetition, and slicing. And we'll also see special methods in strings as we continue. But for now, again, this is introduction to data types, and I wanted to touch base. I wanted to just kind of like introduce you to different data types. The thing to understand with these data types as we go is that we are going to expand on them, and as you'll be able to see, there are different methods that you can use with strings in Python. There's the string.capitalize to make this all capital. I can maybe try to show you that. So we can say, print my string.capitalize, print, and then I'll say my variable, my string dot capitalize. And if I click on run, I'm gonna get hello world in capital letters. The first letter in capital letter. You see the world here was capital, but we just capitalize the first letter, the hello, the first letter, the H in the hello. You see here we have hello world, but the world in our case here was capital W, but now it's small w. So that's one method. We capitalize the first letter of the string. Then we can also use dot upper string dot lower. So if we say like string, we say my string here, print my string dot upper. Now this is going to make this to be uppercase for all hello world. As you can see here, hello world, it's all uppercase. We can also do the same thing, string, my string dot lower. And that's going to give us hello world all in lowercase, as you can see from here. But those are different methods and different manipulations that we can do to string. There's another one called title. There's another one called swap case to change the case. And there's another for strip. But we'll talk this. I'll make another video on string operations and manipulations. And we will be able to go through this all step by step. But in the interest of making this video not as long, and given that this video is just an introduction to data types in Python, I just wanted to introduce you to different data types in Python. And another sequence data type, so this is a string. It can be hello world. These are these are letters. It can also be a string of 1, 2, 3. That's also a string. It can, as long as it's in between single or double quotes, then that's how Python understands a string, and that's how we work with strings in Python. The other one that I wanted to introduce you to is lists. Lists in Python is a sequence data type, and lists are ordered, mutable collection of items that can store different types, and they are enclosed in square brackets. So the same way we saw the way to define a string in Python is to use single or double quotes. The way to denote a list in Python is with the square brackets. Like I can have my list and assign this to square brackets like that. And that is a list. That's a list. And that's how we create list in Python with square brackets. This currently is an empty list. I can put items in this list. I can put an integer there, like 1. I can put another integer there, like 0. I can put a string here, like hello world. World. I can also put a floating point number here, 0.98. And that is a string. See, the string, the way we separate items in a string is with comma, like 1, comma, 0, comma, hello world, comma, 0.98. We don't have to put a comma here, but we could, and it still will be valid. But for the most part, we don't really need a comma when we put the last one, although that will not throw an error. Like I can put a here and I can say print my list, and I spelled list, I spelled list wrong, obviously, so I apologize for that, but I can say print my list, and that will work, and it did not print the trailing comma at the end here. I can also print without the comma, and it works still. So that's how you create a list. That's how you create a list in Python. The most important thing to understand, we saw that strings are immutable. Lists are mutable, meaning that you can change the contents after you create the list. And that's how you create a list. We'll have a full tutorial on lists and see about list operations, including how to append something to a list, how to remove an item from a list, how to slice a list, etc., etc. But for now, I just wanted it to be just introduction. I wanted you to know how you can define a list in Python, and also understand that a list can contain strings, can contain other different items. They don't have to be the same type. Like this one has a float, it has a string, it has an integer and an integer in a list, As long as you have the opening and closing square brackets, then you're telling Python that that's a list. Then I want to also introduce you to another sequence data type in Python called a tuple, T-U-P-L-E-S, tuple. And tuples are similar to lists, but the only difference with tuples and lists, a very big difference, is that tuples are immutable, meaning that once you create the tuple, you cannot change the contents of the tuple, as opposed to a list where you can be able to change the elements once created. So tuples are similar to lists, but they are immutable, meaning their elements cannot be changed once created. And another difference between tuple and a list is that whereas a list is created with square brackets, a tuple is created with parentheses. Like for instance, I can say in my tuple, and we are dealing with tuple, and I can create this tuple by parentheses, opening and square parentheses, and just by that I have created a tuple. My tuple is a tuple. I've created a tuple. The way I've created it is using the opening and closing square brackets. That's a tuple. It's an empty tuple. I can, just as we saw with a list, I can put this tuple, I can put items to this tuple. I can maybe put number 4 in the tuple, number 5 in the tuple, number 8 in the tuple. I can also put my name string in the tuple. I can also put a float in the tuple, like 9.87 in a tuple, like that. And if I come here, I can, we typically don't need the last comma here. And again, the way you separate items in a tuple is by using a comma. So we have a comma there, we have a comma there, we have a comma here, we have a comma here, and we can put a comma at the end here, but we don't really need to. If you put a comma there, that does not make this not a tuple, or it won't throw any error. Like I say print, and I say print my tuple, this will not throw any error, even though we have the comma there. But typically we don't put a comma after the last item in a tuple or list. And if we click on run, it still runs, and that's a tuple. Most important thing again to understand is that tuples are immutable, meaning that their elements cannot be changed once created. And again, tuples, they use parentheses. You use parentheses to create a tuple. In Python, use an opening and closing parentheses, and that's how you create a tuple in Python. As we'll have a whole tutorial on tuples, and at that time we'll talk about tuple operations, including indexing, slicing, concatenation. But we'll talk about that as we continue with our Python introduction series in a different video. But that's how we create tuples. Then I also wanted to introduce to you to another class of data types in Python called mapping types. Mapping types, we'll talk about dictionaries and set dictionaries. So dictionaries store key value pairs, where each key must be unique. They are unordered, but they are mutable and are defined in curly braces. The most important thing to understand from about dictionaries is the dictionaries normally store key value, key value, key value, key value pairs. So everything in a dictionary should have a key and a value, a key and a value, a key and a value. That's the most important thing to understand with dictionaries in Python. And for instance, and there are two ways of creating dictionaries in Python, and I'll show you the first one, which is pretty easy and in line with how we have seen on creating lists and also creating tuples. If I have and I'll call this my dict, and I can assign this to, as soon as I use the opening and closing curly brace like that, the curly braces, then that makes this a dictionary. That's how you create a dictionary. This is an empty dictionary. And as we have seen with lists and also with tuples, we can put items into this dictionary. Remember, dictionaries, key value pairs, key value pairs. We separate the keys and their values with colon. So for instance, I can say, let's say we have a dictionary of names and name of a person with their age and also the city where they live in. So we can have, to define the name, the key, we have name here, and see the way we create a dictionary when we are creating the key and also the key and also sometimes the value, we use double quotes or single quotes to my work. So I have a name here and we separate the key and the value with a colon, and then we have the name, maybe say John. Again, see how we create it. We have a name and the name is in double quotes, colon, then the value of the key name is John. And then to create the age, we use a comma there like that, and then we can say age. And again, we separate key with their values with a colon. As long as this is not a string, like age is going to be a number like 24, 25. So if it's 25, we don't need to put in the double quotes. We just write 25. But for strings, for either keys or values that are strings, then we have to put those in double quotes. And then the city, again, same thing, city in double quotes. And then remember the semicolon, the colons, don't forget them. Then we can say New York, New York City, New York. See, so that's a dictionary. It's called my dictionary, and we have assigned it to this the key value. We have the key name, colon, then the value John, and then we have a comma to enter another key value, then a comma to enter another key value. Separate the key and the value in dictionary with a colon. If you're using a string for your key or your value, you have to put it in single quotes. If you're using a floating point number, integer, then you don't have to use quotes around it, or variables. You don't have to use quotes, but anything to do with string, you have to use a quote. And if I come here and I say print my dict like that, then we're going to have printed there. We have the name equals to John, age colon 25, city colon New York, and we have that. That's how you create a dictionary. That's how you create a dictionary in Python. And I just wanted to introduce you to the concept of a dictionary. The most important thing to understand here is the curly brackets. That's how we denote a dictionary in Python. And also another thing to understand, which is very important, is that dictionaries normally store key value pairs. Key value pairs. The way we separate the key and the value is with a colon, and the way we separate different items, different key value items in a dictionary in Python is with a comma. But that's the most important thing I wanted. I think it's important to know when for basic understanding of dictionaries in Python. I wanted to talk about set types. And the first set type I wanted to talk about would be a set. And sets, S-E-T, sets in Python are unordered collections of unique items or unique elements. And they are mutable but do not allow for duplicates. They are mutable but do not allow for duplicates. Sets are created using curly braces or the set function. I know we created dictionaries using curly braces, and we are now saying that we are going to create sets using curly braces, and that's true. The only difference is that when we are creating dictionaries, we are having key value pairs. With sets, we don't have key value pairs. We just have the set. But the good thing about a set is that it does not allow for duplicates. Like for instance here, if we create a set called mySet, and we assign this to, remember, the way we create a set is we use opening and closing curly braces like that. So that's a set. It could also be a dictionary, don't get me wrong, but what defines it as a set and not a dictionary is that a dictionary will have key and value. Key, comma, value. Key, comma, value. That would be a dictionary. A set may have 1, 2, 3, 4, 4, 4, 4, 4, 6, 6, 6, 6, and another 6. So if now we have this, we have created as a set because we have used curly braces, but it has duplicates. You know, our variable has duplicates of 4 and 6. If I click on run and I run this, well, I have to print first. If I print and I print my set, and then I click on run and I run this, then you see that we just have 1 on the, in our set here, we just have 1, 2, 3, 4, and 6. We don't have the duplicates. That's the thing with a set. It's actually very useful in real life because most of the time you don't want duplicates, and that's how you can accomplish that. That's how you create a set. This can be numbers, it can be names, like say we have a name John here, and we also have another name here, John. Okay, no duplicates. We have another name here, John. And we also have another name, John. And we also have another name, John. Say you are getting this information from a database and there are a lot of duplicates and you don't want duplicates to be shown. So if you click on run, again, we have 1, 2, 3, 4, 5, 6, and John, just ones. So basic understanding, I wanted to just introduce you to sets and their functionality. The thing with sets is that they don't allow for duplicates, and they are really very useful I have actually used it during my programming and software engineering programs, and they are truly, truly useful, especially when you're dealing with strings and you're getting strings from, or you're getting some data from JSON or from a CSV file and things like that. So, but essentially that's sets, and that's how we create a set. And we also have frozen sets. So frozen sets are immutable fashions of sets. Remember sets, we say that they are mutable, meaning that you can change once you create them. But frozen sets, they also called frozen sets. They are immutable, meaning immutable fashion of sets, meaning that once created, they cannot be modified, but they retain set operations like union and intersection and difference. But we'll talk about set operations when we actually make a dedicated video on sets. But I also wanted you to know that although sets by themselves are mutable, we do have frozen sets which are immutable, and they call them frozen set immutable. Next, I am going to talk about Boolean type. Boolean type is essentially true or false. True or false. True or false. Is it true? True. Is it false? False. And call them Boolean types, true or false. And Boolean types, the good thing about Boolean types is that they actually help a lot with logical operations such as and, or not, and are used to evaluate conditions, like if you have if else conditions, and they are really, really useful. And I'm gonna also make a video on Boolean types, the true or false type. True, it has to be capital T, true. And then we have false, capital F, false. And these are Boolean types. If you want to evaluate whether a statement is true or false, or whether it's raining, you know, you can have the true false within your program or your script. And that's essentially how you can utilize it. We'll make a video on Boolean types as we continue with our series, but I thought it was important to mention it when talking about Python types, just because it's one of the types in Python, and you will actually use this more than you think as you continue with your Python journey. Then we have a none type. And none type in Python represents the absence of a value. It is often used to indicate that a variable or a function has no value. And for instance, none type is going to be none, like that, none. And for instance, we can have a variable called x, assign it to none. And if we print here, print x, then it's going to print none. It's going to print none. But this is a type. This is a none type, like that, none. You may see this if you have things that you have variables that do not have anything in them. They have the absence of a value. They have nothing in them. Then one other thing as I finish up, I wanted to talk about is type conversion, how to convert from one type to another. And Python allows for conversion between different data types using built-in functions. Like we have int to convert to an integer, And when I say int, I mean int function. And the way we denote a function, that's an int function. Then we also have a float function to convert a number to a float. Then we have a string function which converts a number or converts a data type from one data type to a string. Then we have a list function again, and this converts from another data type to a list. And for instance, I'm just going to show you one example here. Suppose we have a floating number, say 10.5, and we want to convert this to an int. We can use the function. Remember, this is a function. And if we say x, or we have another value here called k, which is going to be the integer of x, then we can say int, and then we pass in our x here, like that, x. And this is going to output 10 because it's gonna change this floating point number to an integer. We click on run. We have to print k, and we click on run here, then it outputs 10. You know, we have converted this floating point number into an integer, and that's how we do type conversion. Remember, these are functions. We'll talk about functions later, but for now, we'll see that we have them in opening and closing parentheses. That denotes that they are functions. They're functions in Python. And that's what I wanted to talk about today regarding Python data types. I hope this was helpful. I plan on making a lot of videos in Python and posting them on Python All Day YouTube channel. And if you want more videos and with in-depth explanation, please be sure to subscribe to my YouTube channel so you can be able to know when I upload a new video. Otherwise, love, peace, and I will see you next time. Thank you very much. Happy people of the world. Bye-bye.